As will come the next demonstration given by Wing Hong, Yong Chun Kid, Yong Ching Ho Edward. Their project code is AS01b-21, and the title is QRLEDs for the LCD backlights. The demo group, please start your presentation now, and remember to turn on your microphone and camera. Share the PowerPoint if you have one. Thank you.
Good afternoon, everyone. We are the groups for QRLEDs for LCD backlights. I'm Bobby.
I'm Sunny.
I am Edward. I believe another group has also presented the QRLED for LCD backlights before, but actually we are not exactly doing the same thing. But actually they have already presented some brief idea about what is a LED and the LCD backlights. So maybe I will just focus more on the detail part. Sorry for the noise about the lab. And our QRLED actually has 4 layers, including AS01 solution in the bottom that protects the blue LED chip itself, and the red and green QR solutions for the red and green color spectrum. And the 3 color RGB combined, they will form a white light, and the outer AS01 solution will be a protection to the whole LED from the outside environment. So it will both ensure the efficiency of the color quality and also the stability of the LED itself. And also we have done so many cases about the LED, and it's quite a low fault tolerance task, because if we did each step wrong, and it is impossible to make a good QRLED at last. So it's consume lots of time and trials. So after we have made the mixture of the QRLED, we have the demonstration about the picture. Like we can use HDMI line to connect to the computer and show the image out. We have the approach to use the QRLED in an array in the LCD backlight, so to emit the white light. And after adjusting the power source, we can emit the image from the computer line like this. And we'll do a live demo now. And we will switch the camera to Edward. Hi. Hi, everyone. This is our setup. So, can you guys see the setup now? And when we adjust the power source here, you can see the voltage and ampere. We can adjust to some suitable value. And after we adjust it, you can see the image here. And we will present some image to you. Actually, the main part of our project is reduce the red and green QR materials. So we focus more on the red and green color quality now. This is some more modern image we showed, and applying the red color and blue color. This is a blue filter, the blue tone color, and you can see actually the difference is not that big, because the blue LED is fixed quality, because those LED are actually manufactured. But when we switch to green color, actually you can see it. The green color here, is actually much more whiter. I would describe as whiter or brighter. And the green color in our mobile phone is, in one word, I think our project is doing the white light. So the overall picture, if this become more whiter, is successful. And actually the green color quality is also a good quality, I think. And when we switch to red color tone, I'm not sure that okay, you can see it now. Actually, this is the iPhone 13 Pro here, and this is our LED. You can see the color difference is actually not that big, but our red is much more redder, but the iPhone is much more
oranger because the LED panel they use is actually producing more orange color in red tone. And there are more demonstration. I think for this picture, you can see the blue here. The blue in the iPhone is much more darker, or I'll describe it much more purple, much more dark blue. But our picture is much more lighter in blue, and actually this is a better quality in our contrast ratio when comparing the RG and B picture. So this is actually the demonstration of our plate, and this is foreseeable that you can see the panel here, the white light at the back, and this LCD panel is actually simulating the mobile phone. And actually, when we increase the size or increase the number of QRLED inside, it can actually produce a much more brighter and better quality image at last. And it can actually be developed as a market device, like a very more related to mobile screen or TV screen. So this is the end of our presentation. Thank you.
Thank you.
Okay, thank you for your presentation. And you can answer the questions in the chat box quickly as the time is quite limited.
Thank you from UKDD. Actually, in our project, we have something called spectrometer. And when we do some trials, we have blue LED chips and some color layer on top. And when we measure the three colors, we can have when we measure the quality of them, we can construct a diagram like this. What I share here, construct a diagram in blue, green, and red color. And when the three colors are in the same level or in the same situation, and they will be creating a very perfect white light. So this is one of the aspects that we can evaluate how well our QRLED is to control the three color and to control the final product of the white light.
Yeah, and you can also check a question raised by Professor Choi. Hi, why is the green QR coated over the red QR and not the other way around?
Let me try to explain. It's because you can see the spectrum here. It's actually the three color is in a different wavelength. So we arrange it in the red first and then green to avoid a very, because if we place the green first and place the red, the place here, you can see there's a dome shape here. The place here will be filled up and they are linked together and we will not create free peak here. So we try to use green covering red. And for learn teaching, how to control such many LED, we have the material dispenser that can inject very precise volume of solutions to the LED. Actually, how to control them is very difficult task because there are many fail cases in our project, and we have to do 100 to so many quantity of QRLED to make a perfect one or to make some perfect one and to arrange it. So it's one of the difficulties and major tasks in our task. Yeah, it's controlled by the voltage and ampere we have just present just now with the mobile camera. And we use 0.15A and 3 volt for the input to control 8 QRLED.
Okay.
The transversion is from the, I just now showed the device. It has an HDMI line and a power cable to connect the electronic board in the back, and the data will transfer to this black panel, LCD panel. But without the light, you cannot see the color or you can see the image. So we have to put the LCD backlight under the LCD panel. So the light will pass through the LCD color filter and filter out some color image out. It's just similar idea in all the mobile phone or TV screen. They also have a backlight and some filter in front. So they will have, they will have some filter to create the image.
Okay, if there's no further questions, we will invite the next group.
Okay, thank you so much.
Let's welcome. Okay. Then